Alright, today we're going to be following up on the Orico transparent USB-C NVMe enclosure. I've gone ahead and installed with one of the thermal pads an Intel 660p. And what we have here is a ThinkPad P50. This is a Thunderbolt equipped workstation class laptop, and we're doing a screen record at the same time of everything we're doing. And I have the NVMe drive plugged into the Thunderbolt port. We're going to leave it right there where it's hopefully still a little bit visible. And we're going to go and minimize OBS. Run a rescan now that I've plugged that in. There it is, drive F. We're detecting the Intel SSD. As you can see, I've used it a little bit on and off, just field testing. Temperatures are good. And nothing particularly exciting here. Other than we can see we are using UASP and NVMe Express. So those are the fastest options when we're attached via USB and NVMe. And we're just going to go ahead and start with Crystal Disk Mark. Let's go ahead and make sure we pick the right drive. This is one of the slower NVMe drives. It's a QLC device, so the random read and write performance is not particularly fantastic compared to higher end NVMe drives. However, sequentially and honestly for random on a portable device, it should be more than sufficient to fully saturate what this device is capable of. Looks like we're starting with an 870 meg read. A little lower than I had hoped, but overall not terrible either. I will say, while I've been using it, I've had time to plug this enclosure with the 660p into all variety of USB 3 equipped laptops and desktops. And I really haven't had any particular problems. The sole exception has been my desktop, which has a very specific non-standard USB 3 card in it. I have a card that was chosen for compatibility with things like video capture devices, and one of the normally nicer features of that card is it doesn't supply any additional power to the card via a SATA or a Molex connector, whereas many USB 3 adding cards do. That lack of additional power has prevented those USB 3 ports from running this device, so it is a high power device. With that being said, laptops like this one, my old Yoga, my old T440, any desktops that are natively equipped, and even desktops with add-in cards that supply supplementary power, all work fine. So I think that is a failing on the side of the particular card in my desktop, not necessarily this NVMe device. Normally I just present these as fixed slides, and we're not sitting here watching paint dry, as it were, while numbers are running. But it is good to see. This is the procedure that we go through when we bench things on our dedicated SSD test bench. The drive is installed, we check that everything looks good with Crystal Disk Info or SSDZ. which I would love an updated version of. And then we start. We run Crystal Disk Mark first. Specifically, this is version 6 still. Version 7 actually does report higher numbers on this card, and I will run through that once this is done. However, for the sake of comparison, all devices that we've tested up to now have been run through Crystal Disk Mark 6. And the numbers aren't comparable between the two. There have been updates to the software, which, for the sake of consistency, I have to use the same software version unless I make a change to my whole test suite. We are going to start going forward testing devices with both so that we can make that transition in the future. Alright, we are almost done. We're just running our last 4K test. And these numbers are particularly important when looking at this from an overall standpoint. If I was to compare this to a SATA SSD, well, it's actually performing very well, even being handicapped by the USB controller. Our 4K numbers, our sequential numbers are head and shoulders above any SATA drive, much better than many of the cheaper USB externals we've looked at. This is what we want to see. We were able to take a cheap commodity drive, put it in Enclosure ourselves, and then have a device that was better than many of the alternatives on the market. Now, this isn't quite as fast as another external USB-C drive we have in the pipeline. However, that is a far more expensive device, and I don't think the additional cost is justified when we're looking at an external storage device, with few exceptions. Alright, so we ran Crystal Disk Mark in real time. We're going to go ahead and run through the rest of these really quick. So here's ASSSD. It's identifying this as a J micron device, which we knew when we looked at it in the first place. Much quicker test than Crystal Disk Mark, but we're seeing many of the same numbers. We are seeing a higher sequential read. Part of that is just due to the differing nature in the algorithms that are used. And we'll go ahead and fast forward through this next section until it is complete. Alrighty, so we've got some numbers up here now. These aren't the best numbers we've seen. Many internal NVMe devices turn out better numbers, but they're kind of hard to carry around that way. For an external device, I think this is the best we've seen to date, and definitely the best we will have published to date. Let's go ahead and run one of the better tools in this little benchmark suite. We have this copy benchmark that simulates different types of data. We'll actually do a real-world copy test towards the end here. But I do like this simulated test since it consistently uses the same data every single time. Alright, it looks like we have some results out of ASSSD, and once again, we're seeing better results on an external device than many of the internal drives we've looked at, which is just an astounding feat. So we're going to run Atto really quick. One of the things that is really great about Atto is because it runs through different transfer sizes, we can look at how the drive performs based on different types of data and one comprehensive suite. And what we're really looking for here is any weaknesses in that USB to NVMe controller to see if it falls flat when it gets to particularly large transfer sizes, or maybe it just takes a really long time to reach peak performance. Neither of which is typical of a native NVMe devices. NVMe devices very quickly reach peak performance due to the advantages of their protocol. Alright, so we saw a couple of things here. One very good and one, I'm not going to say terrible, but a little worse than anticipated. The small transfer sizes did suffer, and that is definitely just due to the added overhead of that bridge chip. Honestly, 512-byte files, not particularly common, but they do occur. Most modern file systems, however, you're going to have 4 KB chunks that the operating system is natively working with as a minimum size. And the performance there was good, not great. The larger file sizes, though, what we didn't see, and what we have actually seen before, is we didn't see any kind of drop-off due to the controller overheating. It actually only reached 42 degrees Celsius, and it's not even in the most open air. There's hot exhaust coming out of the back of this laptop just a few inches from where it is. So it's getting warm air in the first place. So to see it not really falter when it reached basically the interface limit, I mean, 10 gigs a second writes and 10 gigs a second reads are both things we saw, is fantastic. The controller chip in the adapter is not overheating. The controller chip in the drive itself is not overheating. All right. And we've got one last benchmark that we're going to run live here. We will do a consistency test. We're not going to do the consistency test live. I will have those numbers in the written review. I'm not expecting great consistency for an external device, but I'm not expecting terrible consistency either. It is an NVMe device, so it does have a more advanced controller than some of the cheaper SATA drives that we've looked at, such as the BX500 with no DRAM cache. But this is QLC memory we're working with as well. So a consistency test on this is going to be interesting. I'm not 100% sure what to anticipate. All right, Anvil's done. I really do love how complete a picture Anvil gives you in a single go. And part of the reason we use it last is it validates some of our results, and it gives us a little bit of information that we didn't have otherwise. All in all, the 4K write is lower than we're normally seeing. We normally see 640 megs written, so the response time there is a little bit high. Response times are high across the board for an NVMe drive, but we've put it in an external enclosure, So we knew that was going to happen. Um, Overall, nothing too surprising. IOP numbers look on target for 4K QD16, roughly 35,000 IOPS. 37, right? Actually, is a little higher. So we've got a relatively solid enclosure. I mentioned I'm going to run the consistency test off camera. That is a 3-hour long test, and that's nothing anyone wants to watch happen in real time. There's nothing really exciting to look at there. So we've gone ahead and finished our consistency testing, and the results that came back are a little bit different than what I would have anticipated. Looking at these, although the Orico isn't inherently the worst device I've ever seen, that belongs to some DRAM-less SATA drives that we've reviewed previously. It actually was outperformed by budget options, and I think this actually comes down to not the enclosure itself, but the drive that we chose to evaluate in the enclosure. The 660p is a QLC SSD, and that means that even more than drives we've seen before, performance is going to decrease once it runs past the capacity of its SLC cache. We see this on TLC drives, although modern TLC drives are nowhere near as bad as their progenitors, and we're basically watching the same thing happen with QLC. We now have 4 bits per cell instead of 3, and some of the things that have carried forward is they're nowhere near as bad as the first generation TLC drives were. We seem to have figured out SLC caching. However, there's still this giant performance drop-off once you've run out of cache, compared to a good TLC or a good MLC drive, which typically wouldn't leverage any cache. And because of that, although a QLC drive is what I would generally recommend putting in an enclosure like this, since it's not expected to be a high-performance data center drive, what we did end up doing is showing a bad consistency result that, like I said, I think is more on the drive that was selected for testing than the enclosure. And at some point I will put a different drive in here and do a follow-up when I have an available MLC or TLC drive that I've reviewed outside of the enclosure, and get an even better performance comparison. And maybe we'll have a follow-up video for that sometime in the next few months. In the meantime, if you really were anticipating using something like this enclosure for a portable database of whatever variety, pick a better drive than the 660p. Get something with MLC memory in it, like a 970 Pro, or get something with good TLC memory in it, like we've looked at. Something like the Kingston A2000 would be a good choice there. Alright, I want to go ahead and thank you for taking the time to watch this, and I apologize if there was any rambling. I also apologize for some of the visuals. This was done on some of our earlier equipment that predated our studio update. If you want to go see how we have changed things to improve the quality of videos going forward, go ahead and take a look at the card in the top right hand corner. As always, our opening and closing music is courtesy of Electrix. Much thanks to them for providing that for us, and definitely go ahead and take a chance to check out their YouTube channel. If you liked what you see and you want to see more of it, go ahead and check out the Patreon link below.